is the degree of this polynomial? Green. How do you know? That 3x, so it's one here, one here, one here. They're all the first power, but here are the green. So even or odd? Odd. Which means, what about our graph? Like, what do we care whether it's even or odd? Ends are going to go opposite. Positive or negative leading coefficient? Negative leading coefficient. Right after the equal sign, there's a negative. What does that mean for us? Why do we care about that? Right side goes down. Let's write down our zeros. Those are coming from each of my factors. X plus 4, I take it and set it equal to 0. X minus 3, take it and set it equal to 0. X plus 2, take it and set it equal to 0. Where will this x intercept be? -4. So x equals -4, because I would have to minus 4 from both sides. Come over here, 1, 2, 3, right here. -4. What about the one in the middle? 3, x equals 3. I would add 3 to both sides. One, two, three, right here. For the very last one, where's that one going to be at? X equals -2. I'm going to subtract 2 from both sides here. I did that one right here. All right, I'm ready to sketch this in. What do I know about the ends? Going opposite ways. Which end goes which way? Right goes down because of that negative leading coefficient. Left goes the opposite way, so left has to go up. Here I have that line coming in from the top, so it has to come out the bottom and connect to my very next x-intercept, wherever the very next one is. Came in from the bottom, so it goes out the top. Goes over to my next one. My graph looks something like that. Number 2. How many total roots does number 2 have? 5. How do you know? Highest exponent. So this is the total number of roots. And then I had that sentence that that word that I remembered, the math sentence rid. Real plus imaginary equals degree. My total is my degree. What else did they tell me? They told me that it has 3 real roots. I'm going to put 3 in the place of real. Well, 3 plus what gives me 5? 2. It has 2 imaginary roots. The rest of our class time today, we'll take any questions you guys have off of the review. Please keep in mind, Friday, absolute last days to submit any and all late homework. This Friday, December 2nd. What did you say? Yes, this homework and review. But this right here is for anything from the whole semester. I don't know how many missing assignments different people have. So I don't know.
How many, homework and how many programs?
I am not sure off the top of my head. If you get into Canvas and you go to assignments, it'll show you all of the assignments that you have. Yeah, that sounds about right. What would you guys like to see? Number 11, absolutely. Number 11 was a review problem. Said we were supposed to factor by grouping. When you see the word grouping, what picture should you draw? What shape should you draw? Yep. So we're going to draw a box, an area model. How many terms does my polynomial have? 4 terms. How many little boxes will I have inside of my spread? 4. So I've got one piece for each little box in here. Where should I put the 4x cubed? First one. Where should I put that negative 27? Bottom right. Yep, bottom right. Does it matter where these 2 in the middle go? No, I'm going to put it in one of those 2 open boxes there. I'm going to put my 12x squared here, and I'm going to put my negative 9x here. What can I take out of both of these? 4x cubed and 12x squared. What do they have in common? Biggest thing. 4x squared. Remember, I have to take out only what they have in common. So they both have a 4, or a 4 can go into both of them. This one has at least an x squared, and this one only has an x squared. I can't take out more than this one has. That's why I can only take out the x squared part. What about this way? Negative 9x and negative 27. Negative 9. So there's a factor. And I'm going to go vertically. 4x cubed, negative 9x. X. 12x squared and negative 27. 3. Positive or negative 3? Positive. All right, so I have x plus 3. 4x squared minus 9. Are both of those fully factored? No. Which one can I factor more? Second one, this one right here. What do we call this special situation? Start with a B. Difference. Yes, difference of 2 perfect squares, or difference of 2 squares. All right, so I know I'm working with things that are perfect squares. What times itself gives you 4x squared? 2x. So each of my factors is going to have a 2x in it. And I'm multiplying those factors together, and 2x times 2x gives me 4x squared. My x plus 3 out in front of here, so I don't lose it. What times itself gives you 9? Yeah, I want negative 3 and positive 3. Why negative and positive? Because I want to get a negative 9. So 3 times 3 gives me 9. Positive 3 times negative 3 gives me negative 9. What do I do with each of those now to find all the roots? What did you say? Set them equal to 0. So here I'm going to minus 3 from both sides. X equals negative 3. There's a root. What about the middle? add 3 to both sides. The 2x equals 3. And then what? Divide both sides by 2. X is 3/2, or what would that be in decimal form? 1.5. There's another root. Very last one, 2x plus 3 equals 0. What do I need to do with that one? Subtract 3 from both sides. And then just like on the other one, we'll divide by 2. So x is -3/2. Or you could write that as -1.5. Three roots. What else do you guys want to see on the root? Number 8. What is our root mean here? 4. 1, 2, 3, 4 x's. Even though that 1 x is all by itself, it still counts. So what does that tell me about my n's then? They go the same way. Even. Leading coefficient, positive or negative? Positive. So what does that tell me? Right side goes up. Let's write down our x-intercepts now. I take each one of my factors and I set them equal to 0. So this is one of my x-intercepts right here. X equals 0, x is already isolated. X equals 0. I'm going to plot that on my graph. Right here. For the next one over, x plus 1, where's my x-intercept at? -1. And then let's subtract 1 from both sides. X equals -1. Plot that one on here too. That's really close to the first one, but that's okay. Next to last, x minus 3 equals 0. Where's my x-intercept at? At 3. Over here. The very last one, I would subtract 3 from both sides. So x equals -3. Right here. We know from that positive leading coefficient that the right side goes up. Left side is doing what? Same thing. So this one is also going up. And I have to find a way to connect these dots. We're going to go all the way through. So if it's coming in from the top, it's going to come out the bottom and over to the next one. In from the bottom, out the top, and over to the next one. In from the top, it goes out the bottom. And over to the next one, almost looks like a W here. What other problems would you guys like to see? Number 10? So 9 and 10, pretty much the same type of question. I'm gonna use that sentence that we did on the bell work. Real plus imaginary equals my total number, which is the same as the degree. What information do they give us on number 10? Tells me 2 imaginary roots, so I'm gonna put a 2 in the place of the I. Did they tell me how many real roots? No, that's what they're asking me for. And then that's gonna be equal to the degree. What is the degree of this polynomial? 7. Here is my degree. So the degree is the same as the total number of roots that are possible. Well, what plus 2 equals 7? 5. Same kind of thing up here on number 9, except they gave me what piece of information? They gave me 2 real roots, so 2, whatever my imaginary is equal to my degree. What is my degree here? 4. Well, what would make that a true sentence? 2 plus what equals 4? 2. 2 equals 4, so there must be 2 imaginary roots here. Right. What else would you guys like to see? Number 6, absolutely. Number 6, I had you guys change the wording on this one, if you remember. I don't want the possible number of positive real zeros. I want the maximum and the minimum. How do I find the maximum? This is my degree. Highest exponent, which is what on this? 4. Circle is 4, bubble in number 4. What about for the minimum? 0. How do I know on the minimum? Like, what are my rules for that? I know that maximum is degree. Even, and it's 0. If it's odd, and it's 1. In this case, we have an even polynomial. So I'm going to bubble in the 0. Number 5. Total solutions. I just want a single number on this. First one is 4. Part B is 3. That's all I needed on that one. Problem number 4, okay. Ooh, this is a good one. If x minus 2 is a factor of x cubed minus 3x plus 2, find the remaining factors of the polynomial. Be sure to fully factor the polynomial. What can I use to factor this? What skill do we have? Synthetic division. So what's going to go in the box? -2. Now, here's where we have to be careful. What number goes first after the box? 1. 1 is the coefficient on what here? X cubed. And then I have to go to x squared. There isn't one, so I have to put a 0. And then I go to -3. And then finally +2. So here's my x cubes. Here's my x squared. Here's my x's. Here's my constant. They got tricky on that one. We haven't seen one like that in a while. So we have to have every single power of x represented when we do this. I will warn you, there is a trick kind of like this on the quiz tomorrow. So be watching for that. Be looking for all your powers of x. All right, I'm going to pull this one straight down. And then what do? Multiply by -2. So I have a -2 here. I'm going to add that to what's up above. I've got a -2. What is -2 times itself? +4. What do I get when I add that to what's up above? Multiply this. I get -2. And I add that to what's up above. I get 0. What does that mean? It is a factor. So this right here. My remainder equals 0. Therefore, x + 2 is a factor. That means I can go on and I can find these other roots. If I had gotten something other than 0 here, it would not be a factor and I'm stuck. I cannot find the roots from that. So I have x squared minus 2x plus 1 as my constant. A little bit higher so I can get my x. And my area model drawn. And A and C. A times C and B. X squared here and C here, so I'm multiplying 1 and 1 together. Multiplies to give me 1, but adds to -2. -1 and -1. Is -1x. -1x. What can I take out of these two? 1x. What about these two? -1. Then going vertically, what can I take out of these two? I can take an x out and these two. -1. I have two factors that are identical. And then I have that factor that they gave me at the beginning, x + 2. So my factors x + 2, x - 1, and x - 1. So where are my roots? 7 to 0. With -2. +1 and +1. We got two of the same root here. This is called a double root. You don't have to memorize that, but I do want to talk about it for just one moment. They didn't have you draw a picture of this one. But if we did, here's what it would look like. I have an x-intercept at -2, and I have two x-intercepts that are on top of each other right there at that one. Did we have a positive or a negative leading coefficient for there? Go up at the beginning. Positive leading coefficient, right? Odd or even degree? Odd, my ends are going opposite ways with a positive leading coefficient, so this side's going this way. This side's going this way. Well, how in the world are those gonna connect? I would go all the way through this one, come over here. Because this is a double root, it actually doesn't go all the way through, it bounces. I did not ask you guys to graph any of those, but I did want to show you what that looks like. To the best of my knowledge, you're not responsible for that tomorrow on the test, but I wanted you to be exposed to it. So whenever you have a double root, it's going to bounce like that. What else do you guys want to see? We still have a little bit more than 10 minutes. Number 3. Oh. Can I use synthetic division on this? Yes, I can. What goes in the box? -2 goes in the box again. And the other numbers? -1, -16, and -1. Do I have all the powers of X represented? Did I miss one and I gotta stick a 0 in somewhere? Here's a trick that you can use. What's my degree on this? 3. You should have one more than that for your numbers because your constant doesn't have an X with it. So if it's a degree 5, how many numbers should you write down? 6. That's something that you can always look for to see if there's a 0 hiding in there somewhere. Bring that first number straight down. Multiply that by -2. We have -2 plus -1. What does that give me? -3. -2 times -3 gives me what? +6. I'm going to add that to the -16 that's up above it. What's -16 plus 6? -10. One more time multiplying. -2 times -10 gives me +1, absolutely correct. Add those together, and I get my remainder of 0. My remainder equals 0. Therefore, what is true? Yep, X plus 2 is a factor. So we can go on and factor this further. X squared minus 3x minus 10. A here, C here, X squared and -10. Multiply A and C together, and multiply a 1x squared and a -10 together. I need two numbers that multiply together to give me -10, but when I add those same two numbers, I get -3. You said -5 and what? 2. So -5x, +2x. What can I take out of x squared and -5x? Taking x out. What about 2x and -10? Take 2 out. Positive or -2? Positive. X squared and 2x. X. 5x and -10. -5. How many factors do we have then? 3 factors. Have x plus 2 that we found at the beginning. And then over here, we had x minus 5. And x plus 2. So I know how to find my roots. You guys have told me that we set these equal to 0. Where are these roots? Where are my roots? -2. +5 and another -2. What do we call this situation again? Double root. What would I see happen on the graph if it was a double root? It's gonna bounce right there, so that my ends can continue to go the directions that they're supposed to. Got about 8 minutes. That's time for 1 or maybe 2 more problems, depending on the problem. What do you guys want to see? Which one? Number 2, absolutely. We're gonna use synthetic substitution. With synthetic substitution, I want to set this up just like synthetic division. And 1, what's my degree here? X cubed, so I should have how many numbers after the box? 4. 1, -2, 7, -2. Are there any hiding zeros? Nope, I've got all 4 numbers. When I'm doing synthetic substitution, what's the only thing I care about at the end? I want my remainder. This is the only thing that I want. Bring this 1 straight down. Multiply that by my -1. Add it to the value up above. -2 plus -1 gives me -3. -1 times -3 gives me +3. I add that to the value up above and I get what? -1 times 10. -10. When I add that to the value up above, I get what? -12 and -2 and -10. So f of -1 equals -12. Part B, almost exactly the same. I have -2 inside the box. I have cubed, x cubed, so I should have how many numbers after the box? 4, it's always 1 more than my degree. That's good. 4, -5, 2, and -6. Only thing I care about at the end is my remainder. And bring down the 4. Multiply the 4 by the -2. Add -8 to the value up above. What is -5 plus -8? -13. -2 times -13. +26, and I add that to the value up above and I get 28. -2 times 28. -56. When I add that to the -6 that's up above, what do I get? Not -50, -62. So what that tells me now is that f of -2 equals -62. Bell's gonna ring in just a couple of minutes. If you guys have any other questions about any of the other problems, please feel free to raise them at the end. I know we did go over problem number 1. And what was the other one we did go over, like number 7, I think. Was the only 2 problems we didn't get to. Number 7 is almost identical to number 8, so we can do number 8, maybe we do number 7. Number 1 is a lot like number 2, these 2 parts here.